All right, so problem one, P and E. All right, I'll just read the problem out here. A train car of mass m1, initially moving at speed v1, moves along a frictionless track and collides completely inelastically with a train car of mass m2 that's initially at rest. So part A asks, is momentum conserved in the collision? How do you know? That's the first question in part A, first couple questions. So we know that momentum is conserved because only internal forces act on the system. And I know that from something that is given in the problem, which is that the track is frictionless. Is mechanical energy conserved in the collision? How do you know? So I can again answer this question based on something that I'm given in the problem, which is that the train cars collide completely inelastically, which means that some mechanical energy is lost in the collision. So in order for mechanical energy to be conserved, only non-conservative internal forces must act, and that's not the case here because some mechanical energy is lost during the collision, so mechanical energy is not conserved. So, problem B asks in terms of m1, v1, and m2, calculate the final velocity of the two-cart system. Okay, so I'm going to use the fact that momentum is conserved, and the momentum before the collision will be the same as the momentum of the system after the collision. So I have a P equals mv, momentum equals mass times velocity. So I'm going to take, since at the beginning of the problem, m2 is motionless, all we have is m1 and v1, which is the initial momentum. And then after the collision, when the two train cars stick together, because the collision is completely inelastic, the final mass will be m1 plus m2, and a v2 is what we're solving for. And then we do some division, and we get the answer right here for v2. So finally, part C in question 1 asks, in terms of those same variables, state how much mechanical energy was lost during the collision. Okay, so I'm going to use my equation K equals 1/2 mv squared. Specifically for this problem, K1 equals 1/2 m1 v1 squared. And then I'll be looking for K2. So I'm going to use the same equation, but because I have a different mass and a velocity, which I've calculated here, I'm going to come out with this for what K2 equals. And then if I want to find how much mechanical energy was lost in the collision, I'm going to do the initial kinetic energy, mechanical energy minus the final mechanical energy, and that will give me the amount of mechanical energy lost during the collision. So I subtract those here, and that's the answer to part C. So one mistake that a student might make during this problem is there are a few places you could fail to realize the things that are given to you in the problem itself, such as what the completely inelastic collision means to the problem, that mechanical energy is not conserved, and also that the track is frictionless, and also since you're asked to give answers in terms of variables, there is a lot of room for transcription errors and kind of confusion in that respect. So those are two places that you might want to watch out for when you're answering this question.